All right, let's begin then. So we are done with three topics already: modulus inequalities, polynomials, and binomial expansion. Now this is the next one that we're doing, which is partial fractions. Let's start this. P3 partial fractions. Okay, now let's first of all try to understand what partial fractions mean. What exactly is it that we have to do in such problems? Let's start with something that you already know how to do. Let's say you have two fractions like this: 5 over x plus 4 minus 2 over 2x minus 6. You have these two fractions and you want to simplify them. So write them as a single fraction. Okay. How do you do this? You find the LCM of the denominators. What's the LCM of the denominators? You just multiply them, right? X plus 4 into 2x minus 6. And then in the numerator, so in order to make the denominator the same, you have to multiply the numerator of the first fraction by 2x minus 6. So essentially this gets multiplied there. And x minus 4, that gets multiplied there. And that leaves you with 5 into 2x minus 6 minus 2 into x plus 4, right? And that will give you the simplified fraction, one single fraction. Now let's simplify this further. The numerator gives you 10x minus 30 minus 2x minus 8. The denominator is x plus 4 into 2x minus 6. We leave the denominator in unsimplified form generally. We leave it in factorized form. This is factorized form. Let's simplify the numerator further, and that will give us 8x minus 38 divided by x plus 4 times 2x minus 6. This is the simplified form of these two fractions, right? That's called taking LCM, right? And converting multiple fractions to a single fraction like this. All of you are familiar with this. You've been doing this for years. This is something straightforward to do, right? Now, what if we wanted to do it the other way around? That we had this fraction and we wanted the two fractions from which this single fraction comes. So we want to break it down. We want to break it down into two parts so that x plus 4 is the denominator of one fraction and 2x minus 6 is the denominator of the other fraction. So we want to find the two parts this single fraction is made of. So it's the opposite of taking LCM. This process in which we go in the other direction, that we break a single fraction down into multiple parts by breaking down its denominator, this is called finding partial fractions. Okay, so when you find the two partial fractions, you have one part here. This is part 1 of this fraction, and this is the second part. This is what this single fraction is made of. So it's the opposite of taking LCM essentially. All right. Now, how is this going to be done? If we have this fraction, how can we go back to those two fractions? That's the question, and that's what you want to learn today. Okay. Let's start with this. So let's say we have this single fraction. We want to break it down into two fractions. 8x minus 38 divided by x plus 4 into 2x minus 6. Okay. Now, we want to break it down into two fractions like this, right? Figuring out the denominator is going to be straightforward because remember when we took LCM, what really was it that we did? We just multiplied the denominators. We said it's x plus 4 into 2x minus 6. So if we want to break it down into two fractions now, we would say that one of those fractions has a denominator that is x plus 4, the first bracket, and the other fraction would have the denominator, which is the other bracket, which is 2x minus 6. So figuring out the denominators is going to be straightforward. Okay, so we have the denominators here now. What about the numerator? How do you get the numerator? That is the difficult part. That's the complicated part. What's the numerator of the first fraction and the second fraction? That we do not know. So what we do is we say, let's say the numerator of the first fraction is a, and the numerator of the second fraction is b. And now the problem is we need to find the values of a and b. Once we have those values, that is all that we are looking for. So we want to find the values of a and b. Okay. So now the problem is reduced to finding these two values, the values of a and b. Now, how do you find the values of a and b? Remember that definition of identity that we discussed earlier. The left-hand side here and the right-hand side, they are basically identical to each other. We talked about identities in polynomials earlier as well. The left-hand side and the right-hand side, these are identical to each other. These are just two different ways of writing the same thing. For instance, let me just remind you about this. In fact, we did this in polynomials. I'll just refer back to that. Where was that? Yeah. So we talked about this in polynomials earlier, the difference between equation and identity. For example, this is an equation. This equation is true when x is equal to 3. The solution of this equation is x equals 3. This is an equation. The solution of this equation is x equals 3 and x equals 4. The left-hand side and the right-hand side, they will be equal to each other when x is equal to 4, right? These are examples of equations. What are identities? Identities are represented by these three horizontal lines like this. Identity is something in which the left-hand side and the right-hand side, they're always equal to each other, no matter what the value of x is. So these are true for all values of x. Identity is something that is true for any value of x. These are just because the left-hand side and the right-hand side, they would just be two different ways of writing down the same thing. So 2x plus 6 and 2 into x plus 3, they are exactly same expressions. These are just two different ways of writing the same thing. So no matter what the value of x you input on the left side and the right side, they will always be equal to each other, which was not the case in equations, because this first equation is only true when x is equal to 3. Okay, so what's an identity? Identity is something that is always true no matter what the value of x is. So when we go here now, this is an identity because the left-hand side and the right-hand side, they are just two different ways of writing the same thing, which means no matter what value of x we input on the left-hand side and on the right-hand side, both of these sides will always be equal to each other. Now, keep that in mind because that is what we will use. That idea is what we will use to find the values of a and b now. So how is this process going to work? Finding the values of a and b. First of all, what we do is we simplify this a bit. We multiply the denominator on the left side on the right side. So we have 8x minus 38 on the left. When we multiply the denominator to the right side, when it's multiplied with the first fraction, x plus 4 into 2x minus 6, when it's get multiplied by this, x plus 4 and x plus 4, they will get cancelled, right? What are we left with? We're just left with 2x minus 6. So on the right side, we have a into 2x minus 6. Similarly, when this is multiplied with the second fraction, 2x minus 6 and 2x minus 6 will get cancelled, and we would be left with x plus 4 there. So we have b into x plus 4. So we have gotten rid of those fractions now. Okay. Now we've gotten this one. Remember, it's an identity. It's an identity, which means we can input any value of x here, and the left-hand side and the right-hand side, they should always be equal to each other. So one idea could be that we put random values of x. For instance, let's input x equal to 0. When we input x equal to 0, that will give us 8 into 0 minus 38 on the right side. Now, don't write it yet. I'm just trying to get to a point. This is not what we'll eventually do, but this is just to make you think that we could input any value of x here, right? If you input x equals 0, for instance, what does that give us? 8 into 0 minus 38. On the right side, we have a into 0 minus 6 plus b into 0 plus 4. And that gives us minus 38 equal to minus 6a plus 4b. And that's an equation that we got in terms of a and b. We could input another value of x. For instance, we could input x equal to 1, and that will give us another equation. So 8 into 1 minus 38. That equals a into 2 into 1 minus 6 plus b into 1 plus 4. And that gives us minus 30 equal to minus 4a plus 5b. And that's another equation in terms of a and b. Now we have two unknowns, a and b, and we have two equations. We could just solve them simultaneously and find the values of a and b, right? Since we can input any value of x, we input 0 and 1, and that gives us two equations. We solve them simultaneously, and that will give us the values of a and b. But could we make it more efficient that we don't have to solve any simultaneous equations as well? Right now, we're just inputting random values, right? 0, 1. What if we are a bit smarter about the values that we're inputting so that we have to do less calculation? Since we can input any value of x, what we do is we input such a value of x that it eliminates either b or a. It eliminates one of those unknowns. For instance, how can I make this bracket 0? What value of x will make this bracket 0? Let's think about it. X plus 4 equal to 0. How does x plus 4 become 0? If we input x equals minus 4. If I were to input x equal to minus 4 in this, b will get eliminated because b will be multiplying by 0, and I would only have an equation in terms of a that I can solve then to find the value of a. So that's what I do. I say, let's input x equal to negative 4. And that gives me 8 into minus 4 minus 38. That equals a into 2 into minus 4 minus 6 plus b into minus 4 plus 4. Now on the left side, I have minus 32 minus 38, which is minus 70. That is equal to minus 14 times a. This gets eliminated, right? Because that's a 0. And we have a simple equation now that gives us the value of a directly. 70 over 14, that is 5. That's the value of a that we were looking for. So the idea is, once you have multiplied the denominator on the left side to the right side and gotten rid of the fraction, you input values of x such that they would make one of these brackets 0. So one possible value of x would be x equals negative 4, for instance, because that makes this bracket 0, and we are left with only a, and we can find the value of a from that. Now we input another value of x that would eliminate another variable, another unknown. How can you make this bracket 0? We can say 2x minus 6 equals 0. What value of x does that give us? X equal to 3. That means when we input x equal to 3, this thing will become 0, and we can find the value of b from that. Okay, I can make it a bit smaller, so just less clutter. X plus 4 equals 0, x equals minus 4. So we had one value which was minus 4, and the other value x equal 3. Let's do that next now. We say, let's input x equal to 3 now, because that will make this bracket 0. So we have 8 into 3 minus 38, that is equal to a times 0, right? This gets eliminated, plus b into 3 plus 4, and we have 24 minus 38, which is minus 14, equal to 7 times b, and the value of b turns out to be minus 2. We have the values of a and b that we were looking for. So what are the partial fractions now? The fraction that we had, we can find the partial fractions of that like this, that a is -2. Sorry, a is 5. So in place of a, we put 5. And in place of b, we put -2. These are the partial fractions that we were looking for. We have broken that fraction down into two parts like this. Now you can write -2 like this, with a plus sign here with the fraction and a minus sign here. Or you could also say that just write the negative sign with the fraction like this. That's the same thing. It doesn't make much difference because this minus can be put with the 2 here as well now. And that's what we were looking for. Remember when we took LCM? These were the two fractions that gave us this fraction when we took LCM. So now using this partial fractions process, we have found those initial two fractions back. That's the idea of partial fractions, that given a single fraction, how can you break it down so that you have the denominators split like this. Does that make sense? Any problems with this? Any problems with this? No? So that's how we find partial fractions. All right. Now let's do an example. I'll be uploading this worksheet today as well. You can start working on this. Please make sure that you're submitting the worksheets regularly. I'll be checking the submissions over the weekend now, as in I'll be checking if they're all submitted or not. You need to make sure that you're attempting questions, checking them from the marking schemes, but you have to submit them, okay? So I'll be going over the submissions this weekend, and I'll be asking those of you who haven't submitted them yet, because that is not going to help. I told you earlier as well, if you're not doing practice alongside, this course is not going to help you. Okay, then you're just wasting your time. Please don't do that. Just attending classes and looking at your screen. Do not think that you understand everything and then you can just go into the exam directly. You have the time that we're spending in these classes, you have to do multiple times that at home doing practice. Okay, that is extremely important. If you don't do practice, just attending classes is not going to help. And the minimum you have to do is you have to attempt the assigned questions that I give you, because that they will make sure that at least all the different details that we have in different topics, you have attempted at least one question on all of them. But I'm sure you understand attempting just one question on every different type of problem that you would see is not enough. You have to do more than that. So please make sure to do a lot of practice. Attempting the assigned questions is just the bare minimum. Start with that, but then do more. And those assigned questions have to be submitted regularly as well. Okay, if you're thinking there's still time, well, there's only just enough time. If you delay it any further, it's going to be very, very difficult to catch up. So please don't leave things for later. We have much more difficult topics coming up next. If you're still stuck with these topics by the next week, then you will see that catching up will gradually become more and more difficult. Okay, please make sure that you're doing the submissions regularly. If you're not doing that, I'll be reminding you about that again and again. But I'm telling you, without practice, there's no point of this course. You can just watch videos on YouTube. Then it's the same thing, right? If you're just watching, then it's not going to be as much help as helpful. Okay. All right. Partial fractions worksheet. Let's have a look at one question quickly from this. This is question number 7 from the worksheet. It says express this fraction in partial fractions. Okay, so how do we start with this? We have this fraction 2 minus x plus 8x squared divided by 1 minus x, 1 plus 2x, 2 plus x. Okay, now what are the partial fractions going to be? We have 3 factors in the denominator. We can get 3 factors from this: 1 minus x, 1 plus 2x, and 2 plus x, right? These are the factors. These are the expressions that we have in the denominator in each of these fractions. In the numerator, we can say it's a here, it's b here, and it's c here. Okay, now we need to find the values of a, b, and c, right? That's what we want to do now, because denominators we already know. We have to find the numerators. How does the process work again? We start by multiplying this denominator on the right side. What's the denominator? 1 minus x into 1 plus 2x into 2 plus x. Multiply that with the first fraction. What do we get when we do that? 2 minus x plus 8x squared. That is identical to 1 minus x and 1 minus x, they get cancelled. What are we left with? We have a times 1 plus 2x times 2 plus x. Then you multiply it with the second fraction, 1 plus 2x and 1 plus 2x, they get cancelled. What are we left with? 1 minus x and 2 plus x, right? So we have b into 1 minus x into 2 plus x. And then finally, the last fraction, when you multiply it by this, 2 plus x and 2 plus x, they get cancelled. What are we left with? C times 1 minus x and 1 plus 2x. Okay. We've gotten rid of the fraction now. Now we need to input some smart values of x that would eliminate some of these unknowns a, b, and c, so that we can find the values of the one that is not eliminated. So think of the brackets one by one and see how you can make them 0. So for instance, this is 2 plus x. How can this bracket be 0? 2 plus x equals 0, x equals minus 2. So this bracket can be made 0 when x is equal to minus 2. So that's what you start with. You input x equal to negative 2. Okay, put x equal to negative 2 here and on both sides, and that gives you 2 minus minus 2 plus 8 into minus 2 whole squared. On the other side, whichever terms have 2 plus x, they will become 0, right? When you input x equal to minus 2 here, this bracket becomes 0. That means this whole thing becomes 0 when it gets multiplied by 0, right? So the first term, all of it becomes 0. The second term also has 2 plus x. That is also going to become 0. Then now we're just left with the last one, and that is c into 1 minus minus 2. And the second bracket is 1 plus 2 into minus 2. Simplify this, and that gives you 2 plus 2, which is 4. 4 plus 32. 36 on the left side, and on the right side, we have c into 1 plus 2, which is 3. 1 minus 4, which is minus 3. That is negative 9c equal to 36. And the value of c turns out to be minus 4. That's the first value that we were looking for. Okay. Now think of another bracket that you can make 0. This is another bracket, right? 1 minus x. How can you make it 0 when x is equal to 1? That's the next value of x you input now. Put x equal to 1. Okay, now when you input x equal to 1, on the left side, we get 2 minus 1 plus 8 into 1 squared. On the right side, whichever term has 1 minus x bracket, that will become 0, right? 1 minus 1 will be 0, and 0 multiplied by anything is 0. That will make this whole bracket 0. Now the first term does not have it. So we can say that is 1a into 1 plus 2 times 1 into 2 plus 1. Now the next brackets, you can write all of that down if you want. For instance, you can say, okay, b into 1 minus 1 into 2 plus 1, and then c into 1 minus 1 into 1 plus 2 into 1. But it's not needed because we know this is 0. We know this is 0. You can save time and just say that they are just going to be eliminated. Okay, they become 0. Now, what are we left with? 1 plus 8, which is 9 on the left side. On the right side, we have a into 3, and a is equal to 1. That's the value of a that we were looking for. Okay. Now, let's look at the last one. Is there any other bracket that we can make 0 now? We can make this bracket 0, right? Now, this is actually going to give you a fraction 1 plus 2x equals 0, x equals minus 1 over 2. If you think that might make you do careless errors because it's a fraction and it's negative, another idea could be that you input x equal to 0, for instance. Since you already know the value of c, you already know the value of a, you only have b left now. So you can actually input any value of x and you can find the value of b because you already know c and a now, right? So inputting 0 will also work if you want to do that. Or if you just want to do it the standard way, then just see how you can make this bracket 0. That gives you x equals minus 1 over 2. Now just be careful in your calculation when you input this, that you're not doing any careless errors. This is x equals minus 1 over 2. Let's input it here. 2 minus 1 over 2 plus 8 into minus 1 over 2 whole squared. Always use brackets when you input any values. That's especially true for negative numbers. Make sure that you write them inside brackets. On the right side, whichever term now has 1 plus 2x, that will become 0, right? So this becomes, the first term is 0. Then the second one does not have that bracket. So we have b into 1 minus x. That means 1 minus 1 over 2 into 2 minus 1 over 2. And then you have 1 plus 2x in the last term already as well. That becomes 0. Now you have to simplify this. The left-hand side, let's see what that gives us. 2 plus 1 over 2 plus 8 over 4. And that is 9 over 2. On the left side, we've got 9 over 2. On the right side, we have b into 1 plus 1 over 2. That is 3 over 2. And 2 minus 1 over 2 is also 3 over 2. That is going to be 9 over 4. And that's going to give us b equal to 2. So we've got b equal to 2. We've got all the values that we were looking for, a, b, and c. So what are the partial fractions then? The partial fractions are let's write them down. A is 1, b is 2, and c is negative 4. These are the partial fractions that we were looking for, and that's our final answer. Okay, any questions on this? No problems? Can I move on to the next thing? Okay, good. Now, this is the method that we will be using for all such questions, okay? However, there's more detail to it. This is just one type of partial fractions that we have seen here. And this is where in the denominator, all the factors that we have, they're all linear and they're all different, okay? They're linear and all different. But there are other possibilities that we could have in the denominators as well. Now let's talk about them. What are those other possibilities? So there are 3 forms that we would have in partial fractions. Let's talk about those three forms one by one. Let's say we have this example. In fact, let me just write down the categories first. Number one, we have non-repeated linear factors in the denominator. This is one possibility that you could have in a fraction, that the denominator has non-repeated linear factors. Now, what does that mean? Let's understand it using an example. Let's say we have x plus 5 divided by 2x minus 1, x plus 3 into x minus 4. Now, you see the denominator has linear factors. None of them have a power of x, right? They're all x power 1. And they're all different. There's no factor that is coming twice or thrice. Fractions like these, they are converted to a form like this, that you have separate fractions for each factor in the denominator. So in the denominator, one fraction is going to have 2x minus 1, the next is going to have x plus 3, and the next is going to have x minus 4. And in the numerator, you have constants like this, a, b, and c. This is the form that we have seen already. This is where you have linear factors in the denominator that are non-repeated. Okay, this is one possibility. But there are other possibilities as well. The second possibility is that you have repeated factors in the denominator. Okay, so now we have repeated factors in denominator. Now, what would be an example of that? Let's say we have 2x minus 3 divided by x plus 5 into x minus 3 whole square. Now, these are still linear factors. Okay, these are still linear factors. These are not quadratic factors. We have a square here. However, it's on the whole thing. X minus 3, this thing is linear. Okay, we say it's a repeated linear factor because this is a compact form of writing x plus 5 into x minus 3 into x minus 3. This is what it actually is, right? X minus 3 is coming twice. It's repeating. And we're writing that as x minus 3 whole squared. Okay, so it's a linear factor that is repeated. X minus 3 is coming twice. Okay. Now, what is going to be the form for this? Since it's a repeated factor, it's actually x plus 5 into x minus 3 into x minus 3. You might first think that it should be a over x plus 5 plus b over x minus 3 plus c over x minus 3, right? We have x minus 3 in the second fraction and x minus 3 in the third fraction. But that's not what it is. You actually have the form like this, that you have x plus 5 as it is. Okay, that's only one factor. So we have one fraction for that. X minus 3 is repeated. For that, we write b over x minus 3, but then we write c over x minus 3 whole squared. This is the form that we have in the case when we have repeated linear factors in the denominator. So the factor that is repeated, we first write that as power 1, and then we write that as power 2 like this. Okay. Now, why is that? Why does that make sense? Why do we have to have a square here? Why can we not do it like I wrote earlier? For instance, why should it not be just this without the square? so that we have a over x plus 5 plus b over x minus 3 plus c over x minus 3. Think about it. If both of these were the same, can't we actually write it as a single fraction so that we have a over x plus 5? Then since these denominators are the same, that would just become b plus c over x minus 3. That would actually become a single fraction. And this is just not, in the numerator, b plus c is just another constant. So you could say, for instance, that's b over x minus 3. So you just have these two fractions left. And if you think about it, when you take the LCM of these two fractions, you do not get this. That would just be x plus 5 into x minus 3. That would not be x minus 3 whole squared. In order to get a square here, we need this to be a square. Remember how we take LCM generally? So some of you do not learn LCM properly in O-levels as well. So let me actually write down a few fractions here and ask you what the LCM of these should be. For instance, if I have 5 over 2x minus 1 plus 3 over x plus 4, what's the LCM of the denominators? In this case, we just multiply the denominators and it becomes 2x minus 1 into x plus 4, and that's fine. But if we have 6 over x plus 5 minus 3 over x plus 5 whole squared plus 7 over 2x plus 3 whole squared plus 8 over 2x plus 3 whole cube. Can anyone tell me what the LCM of these fractions is going to be? What is the LCM going to be? Can all of you write down the LCM of these fractions in the chat box? What is going to be the denominator here? What power of 5 and what power of 2x plus 3? What are going to be the powers? Can I get responses from everyone? Okay, so that's good. You just consider the highest power. We don't just multiply them. It's not going to be that we multiply these two to get power 3 here and we multiply these two to get power 5. We don't multiply them. For the same factors, we consider their highest powers. Okay, so x plus 5, we will just consider the highest power of that, which is 2. For 2x plus 3, what's the highest power? The highest power is 3. This is going to be the LCM. Okay. So if we just had x minus 3 here, the LCM would just have x minus 3 because the highest power is 1. We would not get x minus 3 whole square there. Okay. That is why we need there to be a square in one of these. That is why it's important. Okay. But then there's another question. Why do we not have it like this then? So since we want this to be the LCM, it could also be that we have a over x plus 5 plus b over x minus 3 whole squared, right? This also gives us the same LCM that we want, x plus 5 into x minus 3 whole squared. Now, how do we know if it's this or this? It could be any of them, right? And that's exactly why we consider the first option, because it could be any of these two. It could be this, it could be this. If we consider the first form, it's a general form that will take care of the second case as well. that if it was actually going to be the second case with no term in the middle, when we consider this, the value of b will turn out to be 0 when we do the calculations, and we would be left with this form. And that's all right, because that's what we wanted. However, if we consider this form, if we consider instead of this other form with no middle term, then if it was actually going to be this, we would not be able to get that anyway, because we've not considered that possibility. So we consider all possibilities that, okay, there could be this term and there could be this term. Both of them could be there. We could have x minus 3 power 1 and x minus 3 power 2, both of them there. And then if the middle term was there, we would have a non-zero value of b. And if the middle term was not supposed to be there, we would get the value of b equal to 0. And it accounts for all possibilities. Okay. All right. Now that was just the reasoning behind why we take the second form like this. Okay. But now you have to remember this. You have to memorize this form. Even if you understand the logic behind it, now you need to memorize what this form looks like. Okay. So the repeated factor, what you do with that is you write it as power 1 once, and then you write it as power 2. Okay. That's how you write down the partial fractions form for this case. Now it hasn't happened yet, but there's again a first time for everything. You could have a fraction like this, 2x minus 1 multiplied by x plus 5 whole cube. What if we had a cube here like this? What would be the partial fraction form for this? It would be a over 2x minus 1, right? Plus, this is a cube now. We are going to consider its power 1, power 2, and power 3. So all the powers starting from 1 for the repeated factor are going to be considered. And this form would look like this. Okay. Now, mostly you just need to use the first one. In fact, in all the questions that you find in past papers, but in case they end up giving a cube for some reason, then the format remains the same. The factor that is repeated, you consider all of its powers starting from 1. So if it's cube, you consider it as power 1, power 2, and power 3 in the denominator. Is this clear to everyone? Any question on this? Any problems? You need to memorize this form now. The first form is this, and the second form is this. You need to remember both of these forms. Okay, now the third possibility is that you have a quadratic factor in the denominator. Okay, I'm sorry about that. So I wrote that wrong. You're right. So the numerators will be different. You're right. This should have been C and D. Yeah, so they are all different. Yeah, so it should be A, B, C, D like this. Yes, that's correct. Okay, yeah, so the constants, we can't assume them to be same. I wrote that by mistake. It should be C and D like that. All right, good. Thank you for pointing that out. Now let's move on to the next one, the last one, quadratic factor in the denominator. That's another possibility. That's the third possible case, that you have a quadratic factor in the denominator. Let's take an example of this. Let's say you have x squared plus, or let's just say 2x minus 7 divided by 3x squared plus 1 into x minus 2. So now you've got a quadratic factor in the denominator. Okay. Now for the quadratic factor, you would consider an x term in the numerator and a constant term in the numerator. So it will be ax plus b over 3x squared plus 1. And then this is just a non-repeated linear factor. That would just be c over x minus 2. So for quadratic factors, what's a quadratic factor? In which you have x power something. Okay. If you have a whole power like this, that's a repeated linear. If you have x squared, that is quadratic. And for quadratic factors in the numerator, you don't just have to consider a constant, but you also have to consider an x term, because that's also possible in a quadratic factor. So for quadratic, you consider ax plus b, or bx plus c, or cx plus d, depending on which constants you are using at that point. If it was the other way around, for instance, it does not make any difference. If you had x minus 2 and 3x squared plus 1, you could write that first and this second, and maybe in that case you could use a over x minus 2 here and then bx plus c there. Doesn't make any difference. The form has to be this: one x term and one constant. Okay, that's what you do in quadratic factors. So now these are three different forms that we can have. Let's consider a case that includes all of those possibilities. For instance, if you have factors like this in the denominator, 3x plus 6, x minus 2 whole squared, and x squared plus 4. What about this now? What are going to be the partial fractions for this? And in the numerator, let's say I have 2x squared minus x plus 5. For the non-repeated linear, it will be a over 3x plus 6. For the repeated linear, we would say we have two fractions, one with power 1 and another with power 2. And then for the quadratic factor, we have dx plus e, one x term, one constant. And in the denominator, we have x squared plus 4. This is the form that we could get in this case. Okay, let me write down another example. So I would want all of you to write down the partial fraction form for this. Let's say I have 3 over 2x minus 1 into x squared minus 4. Can all of you write down the form that we would get in this case? What will be the partial fractions form for this? Yes, can I have responses in the chat? Can everyone respond? I don't have any correct answer yet. Think again. Yes. So this thing, x squared minus 4. Yes, it is a quadratic factor right now, but can't we break it down? This is a squared minus b squared. So we can write this as we can write this as 3 over 2x minus 1 into x plus 2 into x minus 2 first of all. So it actually becomes all linear factors. We have to break it down because the idea of partial fractions is we want to break down the denominator as much as we can. Now, since in this case, x squared minus 4 can be factorized further, we first have to factorize that. And then we say the form is going to be 3 over 2x minus 1 plus, sorry, a over 2x minus 1 plus b over x plus 2 plus c over x minus 2. So if you can factorize the denominator, you have to do that. And then you write the partial fraction form like this. X squared minus 4 is not the same as x minus 2 whole squared, Sophia. X squared minus 4 is not x minus 2 whole squared. It's x plus 2 into x minus 2. Remember, indices rules only work with multiplication division. You can't say if you have x squared minus 2 squared, you can't take power common like this. That doesn't work. Just like this is something that's easier for you to remember. X minus 2 whole squared. Remember, it's not x squared minus 4. It's actually x squared minus 4x plus 4 using a minus b whole squared. Okay. All right. So this is what we have in the different forms of partial fractions. These are all the different possibilities. Okay. All right. Now let's quickly have a look at one more example, and then we consider another concept which will complete this topic for us in terms of concepts. And then in the next class, we will do practice on both partial fractions and binomial expansion. Once you've done questions from the worksheet, let's do one of the other two forms now. We did question number 7 earlier. Let's find one that has one of the other forms. This is question number 13 from the worksheet. Let's try this. Okay, so we want to express this in partial fractions. Now, which form is this? This is going to be 3x over 1 plus x into 1 plus 2x squared, right? We have one linear factor. For that, we have a over 1 plus x, and we have one quadratic factor. What do we do with that? That is going to be bx plus c divided by 1 plus 2x squared. Okay, this is the form. You get 1 mark for writing down the correct form. Okay, if you've written this down correct, you get 1 out of 5 marks. Okay. Now we have to find the values of a, b, and c. We multiply this denominator on the right side. First of all, what does that give us? 3x is identical to a into 1 plus 2x squared plus bx plus c. Please make sure to always write brackets here. Don't write it as bx plus c and 1 plus x. That is wrong, because this means that only c is multiplying with this bracket, but this whole thing has to multiply with that. So you write bracket around that. It is going to be bx plus c times 1 plus x. It should be like this. Okay. Now we need to think of some values of x that we can input, using which we can find the values of a, b, and c somehow. This is the first bracket. Can we make this bracket 0 somehow? 1 plus 2x squared equal to 0. Well, we don't get any value of x from that because x squared is equal to minus 1 over 2. That does not give us anything. So the first bracket cannot be made 0. Okay, so we don't have any value of x from here. All right, let's try the other one. Can we make this 0? Yes, this can be made 0 because when x equals minus 1, this becomes 0. So we input x equal to minus 1 as the first value. Okay. When x equals minus 1, that means on the left side we have 3 into minus 1, that equals a into 1 plus 2 into minus 1 whole squared. Now the second term has 1 plus x. That whole thing will become 0. And now we can simplify this. This gives us minus 3 equal to 1 plus 2, which is 3. 3 times a. And the value of a is equal to minus 1. So we found the value of a from this. Okay. Now, what about b and c? How do you find them? Is there any other bracket left that we can make 0? No. We have checked this. We don't get any value of x from this. This we have already used. We got x equals minus 1 from that. And now we have run out of brackets. There's no other bracket that we can use here to make some term 0 or to eliminate sum of the unknowns. We can't do that. So what do we do in this case? Once you run into this problem that you don't have any other brackets left, we try any other random values of x, right? Now, some easy values to work with are x equal to 0, 1, 2, right? Small values that will make your calculation easier. If you haven't used x equals 0 yet, always start with that. So when you don't have any other bracket left that you can make 0, what you do is you say, okay, let's try x equal to 0 now. Now you input x equal to 0 along with the value of a that you have already found. You already know that a equals -1, right? No, in this case, under root is not going to work, Shifa, because 1 plus, you don't get any value of x, because 1 plus 2x squared is equal to 0. That gives us x squared equal to -1/2. We'll get square root of -1/2. We can't evaluate that, right? That's a negative number inside square root. If it was positive, that would work, but even then it would make things complicated. So I would say avoid that. So even if it was positive, avoid writing square root there. That will complicate things. In fact, you won't find any question in the past papers that will require you to use square roots anywhere. You won't really see that. But okay, so once we run out of brackets to make 0, this is the first value we try, x equals 0. Okay, let's do that. On the left side, we have 0. 3 times 0 is a 0, right? On the right side, a is -1. We have already found the value of a. Put that there. Then we have 1 plus 2 into 0 squared, which becomes 0, right? And now putting x equals 0 is helpful because you see what's happening here. B times 0 eliminates b from this equation. So a we already know. When we input x equal to 0, b also gets eliminated, and we are just left with c, and we can find the value of c from there. Okay. So we have 0 plus c into 1 plus 0. Now let's simplify this. This is -1 plus c, and c is equal to 1. That's the second value that we were looking for. Okay. Now we need to find b. Input any other value of x that you haven't used yet. We can input another small value, x equal to 1. Let's use that now. X equals 1. On the left side, we have 3 times 1. On the right side, a is -1. Then 1 plus 2 times 1 squared plus b is what you have to find out. B into 1 plus c. C is 1 into 1 plus 1, right? Let's simplify this. 3 equals -1 into 3, which is -3 plus b plus 1 times 2. 3 equals -3 plus 2b plus 2, and 2b equals 6 minus 2, which is 4, and b equals 2. That's the value of b that we were looking for. So we found a, b, and c. So we know what our partial fractions are now. We can input them there, and that's our final result. The partial fractions, therefore, are -1 over 1 plus x plus 2x plus 1 divided by 1 plus 2x squared. These are the partial fractions that we were looking for. Any problems with this? Any questions, anyone? Okay, so this is how we evaluate partial fractions, right? Now, one last detail that we have here. So we talked about 3 different forms of partial fractions. And they are these, that we have non-repeated linear factors in the denominator, we have repeated linear factors in the denominator, and we have quadratic factors in the denominator. Now, there's another thing that can change in these fractions. All of the problems that we have done until now, all of the questions that we've done until now, all of them were actually something that we call proper fractions. All of them were proper fractions. We can have improper fractions sometimes as well. Okay. Now, what are improper fractions and what are proper fractions? You already know that for numbers already, right? Improper fractions are where numerator is bigger than the denominator, right? Let me write that down. So for numbers, for instance, you already are familiar with the difference between proper fractions and improper fractions. So for instance, if I had a fraction like this, 3/7, this is a proper fraction, right? Because numerator is smaller than the denominator. If I had, on the other hand, for instance, 10/7, this is improper because numerator is bigger than the denominator. And you often used to write improper fractions in mixed form, remember? So 10/7, what you would do with that would be that you would say, divide 10 by 7. 7 times 1 gives you 7, and that gives you 3 as the remainder. And then you could say 10/7 can be written as 1/3/7, right? Or that's the same thing as saying 1 plus 3/7. You could break that down like this, right? Mixed fractions were often written when you had improper fractions. Now that was for numbers. For numbers, this was the definition of proper and improper fractions. When the numerator is bigger, that's improper. When numerator is smaller, that's proper. Okay. Now, what about polynomials like this? When you have something in terms of x, how do you define proper fractions and how do you define improper fractions? Let's understand that. First of all, we need to understand a terminology that's called the degree of a polynomial. Degree of a polynomial. What's degree? Degree is the highest power of a polynomial. Highest power of a polynomial in simplified form. Highest power of a polynomial in simplified form. That's what degree of a polynomial means. For example, let's say we have a polynomial that looks like this: x cubed plus 3x minus 2. What's the degree of this polynomial? It's 3 because the highest power is 3. Okay. If we have 2x raised to the power 4 minus 2x squared plus x minus 7, what's the degree of this polynomial? It's 4. If I have x plus 1 into 2x plus 1 into 2x squared plus 1, what's the degree of this polynomial? Anyone? What's the degree of this polynomial? 3, right? Because when you simplify this, x into 2x squared, the highest power is 3. Similarly, if you had 2x plus 1 into 1 plus x whole squared, what about this? This is also 3, right? Because you have x here. From this, you would get x squared. X squared into x, the highest power in simplified form is going to be 3. Okay, so you understand what degree of a polynomial is. Now, what are proper and improper fractions? A proper fraction is one in which the degree of the numerator is less than the degree of the denominator. So in proper fractions, degree of numerator is less than the degree of denominator. These fractions are proper. Okay, just to clarify it for anyone who did not understand this, when you simplify this becomes 2x cubed. The highest power term, and you have plus something else. The highest power is 3, so degree is 3. Okay. Similarly, the next one as well. if you were to simplify this, you have 2x plus 1, and then you have the other bracket is 1 plus 2x plus x squared. When you multiply them, the highest power term is going to be 2x cubed again. So the highest power is 3. Degree is 3, therefore. So what are proper fractions? Proper fractions are those fractions where the degree of numerator is less than the degree of the denominator. And then what about improper fractions? Improper fractions are those fractions in which the degree of the numerator is greater than the degree of the denominator. Okay, these are improper fractions. When degree of numerator is smaller, that's proper. When degree of numerator is greater or equal, that is improper. Now, in your syllabus, for partial fractions, you only have that case in which the degree is equal. The greater case is not tested in partial fractions. Okay, so only the equal case is tested in partial fractions for improper fractions. Okay. Now, let me write down a few fractions here, and you need to identify if they're proper or improper. So let's say I have x plus 3 divided by 2x squared plus, or 2x squared plus 1 into x plus 5. Is it proper or improper? Numerator has a degree of 1, denominator has a degree of 3. That is proper. Okay. If I had 2x cubed plus x squared minus 1 divided by x plus 1 whole squared into 2x minus 1, is this proper or improper? This is improper because we've got 3 as the degree of the numerator, 3 as the degree of the denominator. They're both equal. If they're equal, that is improper. Okay, so you get the idea. All right. So all the fractions that we have seen until now, in partial fractions, they were all proper. Okay, you can see this. 1 in the numerator, 2 in the denominator, that's proper. Question number 7 that we did, we had power degree 2 in the numerator, degree 3 in the denominator, that's proper. All of these examples that we did, they were all proper fractions. Okay. So all of these forms that we wrote there, they only work when it's a proper fraction. Okay. So that's the first thing that you always have to check when you are finding partial fractions of something. You have to check if the fraction is proper or improper. You always have to do that. You always have to check for that. Okay. So these were forms for proper fractions. Now, what if you have an improper fraction instead? How do we deal with that? That's the question, right? So instead of this, what if we had improper fractions now? So I'm going to change these fractions a bit. So the first one, for instance, if it was x cubed plus 5, that becomes an improper fraction, right? Then this one, let's say it was 2x cubed minus 3. This one, let's say it was x power 4 plus 2. And then 2x cubed minus 7. Right? And so on. So let's say we had improper fractions now. In improper fractions as well, we could have all of these different forms: non-repeated linear factors in the denominator, repeated linear factors in the denominator, quadratic factor in the denominator. We have all of these possibilities there. Okay. But now these fractions are improper. How do we deal with these improper fractions? Let's try to understand that. So let's say we had to find partial fractions of 2x cubed minus 5 minus 5 divided by x plus 5 into x plus, or let's make it simpler. Let's say we had 2x squared minus 5 in the numerator. In the denominator, we had x plus 5 into x plus 1. Let's say we had to find partial fractions for this. Now, is this proper or improper? This is improper, right? This is improper because numerator has a degree of 2 and the denominator has a degree of 2 as well. Okay, this is an improper fraction now. Now, how do we find the partial fractions for this? Now, the proper mathematical way of doing this, as in complete process of doing this, is that first of all, you do division. Just like when we had, I gave you an example of 10/7. If you had to break it down and make it a proper fraction, we would say this is 1 plus 3/7, right? I showed you how to do that. Okay. Now, in this case as well, the proper way of dealing with this would be that first of all, you do this division. You divide 2x squared minus 5 by this denominator, which simplifies to x squared plus 5x plus x, which is 6x plus 5. So you first of all do this division, see what you get from that. X squared into 2 is going to give us that. So we have 2 in the at the top here, and then we have x squared. So add a 0x here. X squared plus 2x squared plus 12x plus 10 here. We change the signs, and that becomes minus, minus, minus. This gets cancelled, and we have minus 12x minus 15. This is the remainder. And then we write this fraction as quotient. Remember polynomials, quotient plus remainder over divisor, right? Quotient is 2 plus remainder, which is minus 12x minus 15, divided by the divisor, which is x plus 5 into x plus 1. And now this is a proper fraction. You find partial fractions for this like this: a over x plus 5 plus b over x plus 1. And you have this 2 on this side. This is how the proper way of doing this would be, right? That you first of all do this long division, convert it to a proper fraction, and then find partial fractions for this, right? That's how you would do it. So you have a separate constant on this side, which is the quotient from this division. That's one way of dealing with this, that we first do this division and then find partial fractions. But there's a more efficient way of doing this. There's a shortcut to this. And that is that we don't actually do this division process to find the remainder here, but just deal with it directly. Now, how will that work? This is very important now. Just last few minutes and then we end. Whenever you have an improper fraction, so in this case, the first case, for instance, it's an improper fraction. Numerator has a degree of 3, denominator has a degree of 3. That's an improper fraction. Whenever you have an improper fraction, use the same form as before with just an additional constant. Just add another constant to it. You can add that in the beginning or at the end, that doesn't matter. Let's say I have another constant like this: a plus b plus c plus d. So everything remains the same as before. Now, you won't have to do this. This is just, I was just trying to explain how the logic of it works, that you first convert the improper fraction to a proper fraction like this, and you have a constant on the side like this, and then you find partial fraction. That's a longer way of doing this. But there's a more efficient way of doing this, and that is that whenever you have an improper fraction, in the forms that we studied before, just add another constant on the side. Okay. So for all of these forms now that we had below as well, just add another constant. You can add it in the beginning or at the end, doesn't matter. Mostly in the standard forms, they add it in the beginning. That's why I'm adding it at the beginning. But since we're just adding, we're just doing addition. It doesn't matter if we do it in the beginning or at the end. But that's the only change that we have another constant like this. In all of these forms, we have this additional constant now. Okay. These are the forms for improper fractions. And now finding this constant is actually fairly straightforward. If you had to find the value of a, let me write that down here. For finding the value of a, the additional constant, all you have to do is divide the highest power term of numerator by the highest power term of denominator. That's all that you have to do, and that will give you that additional constant's value directly. So you can say a, the additional constant, is going to be this. Highest power term of numerator divided by highest power term of denominator. So for instance, in the first case, what's the value of a that we've got? A would be highest power term of numerator, x cubed, divided by highest power term of denominator. Let me just add some space here so I can write that down. Okay, so in this case, for instance, the first example, just divide the highest power term of numerator by the highest power term of the denominator. What's the highest power term of the numerator? X cubed. What about the denominator? Simplify them. 2x into x into x. What do you get? 2x cubed. So a is equal to 1 over 2. All right. And you can write down the value of 1 over 2 here directly. Similarly here, what's the value of a? 2x cubed in the numerator. In the denominator, x into x squared from here, that will be x cubed. And that will give you a equal to 2. In this case, a equals x power 4 from the numerator. In the denominator, 2x into x cubed, that will be 2x power 4, and that will be a equal to 1 over 2. In this case, a is equal to 2x cubed divided by x into 3x squared, that is 3x cubed. And the value of a, therefore, is 2 over 3. So you can find the value of this constant directly. Why is that? Because remember, when we're doing this division, this constant represents the quotient. And how do you find the quotient? That's exactly how you find the quotient. You're dividing this first term by this first term, right? 2x squared over x squared. That's how you find the quotient. We can do that without writing all of that down. We can say just divide the highest power term of the numerator by the highest power term of the denominator. And you get the value of this constant already. Once you have this value, the rest of the process works exactly as before. Nothing is different. Okay, so that's how we do that's what we do in improper fractions. Whenever you have an improper fraction, you have an additional constant in the standard forms. Okay, And then the rest of the process works exactly as it did before. Okay. Now, just for the sake of completeness, I'm really sorry for taking more time. What I just want to do very quickly is do one example, because then you will be able to complete the worksheet after that. So I'll do this an example on improper fractions so that you can then attempt the rest of the questions from the worksheet very quickly. Just a few more minutes. This is question number 15 from the worksheet. Now, whenever you're finding partial fractions, which one is this? No, 16. Question number 16 from the worksheet. Whenever you're finding partial fractions, the first thing you always have to do now is figure out if it's a proper fraction or an improper fraction. That's the first thing you always do. So in this case, the degree of the numerator is 2. The degree of the denominator is also 2. Is it a proper fraction or an improper fraction? It's an improper fraction. That means the form that you use is going to have an additional constant. So we start with an additional constant, and then it's non-repeated linear. It's going to be b over x plus 1 plus c over 2x minus 3. And now, how do you find the value of a? Divide the highest power term of the numerator with the highest power term of the denominator. That gives you 4x squared divided by x into 2x, which is 2x squared. That means the value of a is 2. Okay, so now this form actually becomes this. Once we have already found the value of a, it becomes 2 plus that, right? We input the value of 2 there. Now just follow the process that we used to before. Multiply the denominator on the right side, but when you do that now, be careful. It will also get multiplied with 2 here, right? So it becomes 2 into x plus 1 into 2x minus 3 plus b into 2x minus 3 plus c into x plus 1. And then you input some values of x like you did before. How can you make this bracket 0? You can put x equals minus 1 for this. Put x equals minus 1 on the left side. You have 4 into minus 1 whole squared minus 7 into minus 1 minus 7. Sorry, minus 1. That equals 0. This bracket becomes 0, right? Plus b into 2 into minus 1 minus 3 plus 0. On the left side, you have 4 plus 7 minus 1, which is 10. That equals minus 5 times b, and the value of b turns out to be negative 2. Put another value of x. How can you make this bracket 0? This bracket can be made 0 if you input x equal to 3 over 2, right? Let's input that next. Let's input x equal to 3 over 2. Put that on the left side, and that will give you 4 into 3 over 2 whole squared minus 7 into 3 over 2 minus 1. And that equals 0 plus 0, because the first two terms both have 2x minus 3. And then you have c into 2 over 3 plus 1 on the right side. Sorry, 3 over 2. 3 over 2 plus 1. And then it simplifies to 4 times 9 divided by 4 minus 21 over 2 minus 1, which is minus 5 over 2. On the left side, I have minus 5 over 2. On the right side, I have 5 over 2 times c. So the value of c turns out to be negative 1. And that's it. We've got the partial fractions that we were looking for. The partial fractions look like this. The value of b is negative 2, and the value of c is negative 1. These are the partial fractions that we wanted. So for improper fractions, we just add that extra constant. We can find that value directly like this. And then the rest of the process is the same as before. There's nothing that changes there. Okay, does that make sense? Because that completes our partial fractions topic, at least in terms of concepts. We will do more practice in the next session when it gets combined with binomial expansion as well. I'll upload 2 worksheets, one that only has questions on partial fractions, another that has binomial included along with partial fractions, I would recommend that you attempt as many questions as possible from both the worksheets, so that on Monday, we wrap this topic up by doing practice. So on Monday, we'll just be doing practice questions, so that in the next class, then on Wednesday, we start logarithms then, inshallah. All right, so that's it for today. If you have any quick questions, you can let me know. If you don't have any questions, you're free to leave, and I'll see you again on Monday, inshallah. If you do have any questions, you can let me know. Allah Hafiz. Yes, Nabiya.
Assalamu alaikum, sir.
Alaikum
So, sir, is it necessary to show that the working to find the constant, which is a in the beginning for improper fraction?
No, you can do that in your head, and that works. You can write down the value of a directly. You don't have to show any working for that.
Okay, sir. Another question is also, is it necessary to write the last line where we put the value of the constant in the inequality?
Okay, so it's not necessary generally. Once you have these values, then writing this down is not necessary. I recommend that you still do it at this point, because what happens in the exam is you have this part of the question on one page, okay? And then on the next page, they either have binomial or they have partial fractions. And they have binomial or they have integration. Okay, these two questions generally come combined with partial fractions. In that second part, you have to use this expression. If you write it down here, that will save you from careless errors, because a lot of careless errors happen when you write this down on the next page directly. A lot of people end up copying the wrong values of A, B, and C. So if you write it down once on this page already and then copy it from there, in my experience, that saves you from some careless errors. But if you just can avoid those careless errors, you don't lose marks, even if you don't write it here. Because in the first part, they only mark this form if you have got this right, and then if you've got the constants right. Okay, so you don't necessarily have to write down this final result at the end. But I would still encourage that you do that, because it will save you from careless errors in the next part, because you'll save yourself from copying wrong values there. Is that okay?
Yes, sir. Thank you, sir.
All right. Any other problems? Any other questions? Yes, Vanya?
Sir, I wanted to ask you that one of the questions you did, there wasn't more than, like, when we equate the brackets to 0, you could only do that once. So you were like that, you said that we could just input any x value, like we could input 0 or something. So I didn't really understand that.
Okay. Why can we input x equals -1 here? Any value of x that we're inputting, we can input that because it's an identity, right? It's an identity, and we discussed earlier, an identity is something that is always true, no matter what the value of x you have on the left side and on the right side. So that is the reason we can actually input any value of x on both sides, and the left hand side and the right side would be equal to each other. These values of x that we're inputting, we put them generally in a way so that some variables get eliminated. For example, we try to make the brackets 0 so that when they become 0, they take with them some of the unknowns. For example, when this bracket becomes 0, it will eliminate B and C, and we would only be left with A, and we can find the value of A from that. Now we can choose some smart values when it is possible. In this case, it was possible only for this particular bracket. In other cases that we saw earlier, we could do that for multiple brackets. We could do that for this bracket, and this bracket. Sometimes it's not possible to do that for all the brackets that are there in a particular question, all the expressions in the bracket that are there in the question. This was one such example in which we could only make this particular expression 0. We did that to find the value of a. And now we are stuck that we don't have any other expression inside a bracket that we can make 0, because this cannot be made 0. So we go back to the basics and we say, okay, remember, it's an identity. It's an identity. We can input any value of x. That's the idea in the first place, that any value of x will satisfy both sides of this equation. So we input any other value of x, but those other values of x that we choose now as well, we choose them in a way that they are very simple to evaluate, very simple to work with. So small positive numbers are 0, because they will save you from careless errors. 0 is a good choice as the first number that you input, because in a lot of cases, that will eliminate another variable as well. For example, in this case, when you input x equal to 0, what happens is you have b times x here, and that eliminates b as well. A we already knew, so we can find the value of c from that. So choosing 0 in such cases is the best choice as the next number. Then if you've already when you've already used 0, then you can choose any other small values of x, 1, 2, 3, like that. Because again, the idea is any value of x will work, right? Any value of x will work because it's an identity. Both sides will always be equal to each other. We just choose values that make our calculations simpler.
Oh, okay. Thank you. I get it.
Okay. So what's the takeaway from that? You try to make some bracket 0 when possible. When you cannot do that anymore, you put x equal to 0. Then you put x equal to 1, then you put x equal to 2, and that's the maximum that you would have to do, and you will get all the values of the constants. Okay?
Okay.
All right, any other questions? All right, good. So that's it then. I'll see you again in the next session. Please make sure to attempt the worksheets so that if there are any problems, we could discuss them in the next class. Allah Hafiz.